Hello, welcome to another video. Today we're going to be looking at something called the Serverless Framework. It's basically an infrastructure as code tool for AWS, a bit like Terraform or CloudFormation, but it's really aimed at serverless applications. So it's really good if you're using lots of Lambdas or DynamoDB, SQS, and you'll see in a second that it's far easier to write than Terraform or CloudFormation. It's far more user-friendly. So let's jump right in. The first thing you need to do is install serverless. So it's an npm package, so we can just run npm install global serverless. And I should already have this installed, so it shouldn't take too long for me. But while it's installing, please subscribe to the channel if you're following along. Let me know if you run into any issues. Always happy to help you out. Okay, so that's it installed for me. Oops. And once we've done that, we can run this command serverless, and it gives us a few options. So we're going to use a template starter just to begin exploring serverless today. We're going to use Node.js, and we'll use the HTTP API. So we're going to, and we'll just call it the default. It takes a wee second to download, but yeah, we're just going to, don't want to register to the dashboard just now, and don't want to deploy yet. Okay, so that should be it done. What was it called? AWS Node HTTP API project. So yeah, we're gonna, this is gonna create for us, and you'll see how simple it is compared to Terraform. Oops, I meant to open it up in Visual Studio. You're gonna see how simple it is to create an API gateway, basically with a Lambda underneath it. Let me zoom in a bit into. Okay, don't need it that big probably. That'll do. Try and make that a bit smaller. There we go. So let's just have a look at what it's given us here. So we've got this serverless file, which is like main.tf or a CloudFormation file, and this is all it needs to deploy a Lambda function and an API gateway in front of it. So it's very lightweight compared to Terraform. So we have a functions block with a function called hello. We give it a path to a handler, so that is the handler.js. And then this hello function is the entry point for the Lambda. And you can define events on that. So here we've defined a HTTP API. You can also define SQS, all sorts of events you can define on your Lambda. You could define a Cron Job. I've forgotten exactly what that looks like. Let me have a quick Google. So if you want a cron job, it's called schedule, and then you give it a rate. So we want it to fire off every 1 minute, and that'll create a CloudWatch event for us. So everything is created with a very small amount of configuration in serverless. So this compiles to CloudFormation, and then it'll deploy for us. So let's have a look at how we can deploy it. So if I open up a terminal, similar to, there's a few different ways, but the way I like is just to put our AWS credentials in as environment variables. So we need an AWS access key ID and then AWS secret access key. So these will be for your IAM user. You can create that in the console. Press enter, and then we should be able to run serverless deploy. And that's all that's needed. And it takes a little bit longer probably than Terraform does to deploy, but I'll pause that while it's creating. Just point out a few things while that's still deploying actually. So first thing, as you can see here, it's saying deploying to HTTP API project to stage dev. So that's the service, so you can give it any service, and stage is important. So stage makes it very easy to deploy different environments within the same AWS account. So the command we passed in there was serverless deploy. Oops, serverless deploy. Okay, we can also give it a parameter stage, and then you could say dev, which is the default, or production or non-prod or whatever your environments are called, and it will basically use this staged namespace thing. So the function isn't actually only called hello. I think it's called something like hello Lambda Function dev or something. So it includes the stage name. So if you have non-prod, it'll create a non-prod version of that as well. So it's very easy to deploy the application, multiple environments to the same AWS account, or to different AWS accounts, but just namespace like that. Okay, so that's now deployed. So if we jump into the AWS console, we can go to, well, let's go to CloudFormation actually first. So CloudFormation has this concept called stacks, which is your projects basically. So we've got a stack which deployed a couple of minutes ago, and from here we can see some information. So we can see the resources, so you can see all the resources that this single config file here created. 14 lines created all of this. So we've got a Lambda function, it's got a permission on the Lambda, and then some log groups, API gateway, IAM role, S3 bucket. So you can see it's far easier than if we were to try and terraform all of this up. It's really nice for simple little applications. Okay, so let's have a look in API gateway, or actually we can just click through from here. So the API gateway, where's it gone? There we go. And also let's open up the Lambda function. So that's this one. So on the Lambda function you can see the triggers. It has an API trigger with an endpoint, and actually let's just hit that endpoint and see what we get. So we get this message here: go serverless version 3, your function executed successfully, and then the input that we sent. So and if we look in handler, we can see that is exactly what's returned from the Lambda. So the message and then the event that we sent to the API. Oops. So I think that's everything we want to look at just now, really. I was going to show you the API gateway as well, but that's not too interesting. But you can see it's got a get route and see any details you want to see. And you can see that that is integrated with a Lambda function. And if you want to try changing anything for the console, you can, but as soon as you deploy it, it'll just change back to what we have in our serverless file. So let's try writing our own function. Let's try writing a function called create customer. So as well as having functions, we can have other resources defined. So for this function, what we're going to do is we're going to allow the user to pass a body with some information to the Lambda function. It's then going to create an entry in the DynamoDB table, which is serverless database in AWS. Serverless schemaless databases are quite useful for this sort of thing. So we're going to have the function in a folder called source, create user, and then the actual function is going to be called create customer. So let's create that. Source, create customer. Oops, that should be a JavaScript file. It's worth saying here as well, you don't need to use JavaScript. You can write your functions in any of the languages that Lambda can run. Okay, and then attached to this, it's going to be triggered by an event. HTTP API again. Just the base path, method post. Okay, and then we need our DynamoDB table. So it's defined in a separate block called resources. And then we need our resources again, and we're going to call it customer table. and that is an AWS DynamoDB table. So for anything that you can't write natively in serverless, you can also just write it in CloudFormation as well. So it's really not restrictive. So don't worry about beginning to use serverless and then need to build things on top of it. You can just define them in the same file, and when it compiles to CloudFormation, it'll just leave them as you wrote it. So we're going to have attribute definitions, attribute name, primary key, oops, and that is going to be a string. So attribute type S, capital S, and then billing mode, pay per request. We don't want to provision any compute power. Just want to pay when we hit it. Key schema mode, key schema, and then another attribute. So the key schema is going to be the hash of the primary key, and then we need to give it a table name. So here we can say self-service, and that is given to us by serverless. It's just the service name up here, so you can refer to other things in your file as self. So say I wanted to refer to the function name, I could say like self functions dot create customer dot name, I think, or you can double check that, but if you wanted to do that, but we're just going to call it self service customer table. And then this is what I was talking about earlier, so we've got SLS stage as well. So that's useful if you want to deploy this multiple times. Your Dynamo tables need unique names, so the stage will be what guarantees uniqueness there. Okay, let's write our function now. So this function, we're going to use the AWS SDK, which means we need to install it or import it as a dev dependency. And then, oh sorry if you couldn't see that, I just ran npm install savedef AWS SDK to import that dependency. Then we want to export a function called create customer, which is going to be asynchronous, and first thing we're going to do is going to get the body, parse it as a JSON event, and then get a DynamoDB client. And then we need to set up the put parameters. It's going to be table name process.env, and you'll see where I'm getting this environment variable for now. Second, we'll set that up. And then item, primary key, going to be the name, and then oops, that should be body.name, and then we can define any other fields because it's a schemaless database. So let's say body.email for email. Okay, and once we've got that set up, all we're going to do is await dynamodb.put params.promise. That should throw any errors if there is any. If there's not, we're just going to return status code 201. Okay, and let's set up this environment variable here now. So this, we can add it in the serverless file. So you can add environment variables under provider. Oops, as environment, and then that way the environment variable is put onto all your lambdas. Or you can actually just put it on a specific lambda by doing the same thing, environment. In this case though, we're going to create a second function to get the users, so we'll want that environment variable available to both of them. So let's just put it here. And it's DynamoDB customer table, and we need the table name, which is here. And a nice way to do this would actually be to reference it as resources.resources.customer.table name. So let's do that actually. So let's try doing I haven't rehearsed this bit, so hopefully it just works, but I think that should work. Self resources customer table name. Oh, it should be properties actually. And that way if you change it, then it will come in here. Okay, you can also, let's do it this way as well actually. So you can also set up something called custom, custom block variables, and then we could say Dynamo table name, and then rather than define it here, we can define it somewhere where it's a bit more obvious that we're defining it, a bit easier to change it, and then that way we can say self custom.variables Dynamo table name, and that should also go down here now. Okay, right, let's try deploying that. So to deploy, if you remember, we just run serverless deploy. Okay, that's deployed now. So we've actually got our function names and endpoint here, so it's quite useful if you don't need, maybe you don't want to go into the console at all, but we're just going to quickly have a look at that in the console. So if we go back to Lambda, you can also go to applications here, and it creates an application so we can see our different functions. Hello Lambda function and customer table now, which is a DynamoDB table, and create customer Lambda function. So we go to this one. It doesn't have a trigger, something's not quite worked there, so we'll look at that in a second. Configuration though, hopefully environment variables. Yeah, you can see we've got our customer table name and it's populated that with a value. So why did the trigger not work? Oh, here we've not indented these to the right level. So I'll indent those, run serverless deploy again, and come back when that's deployed. Okay, that's deployed again. If we go back to our Lambda, we now see this event API gateway, and it tells us it doesn't tell us it's a post request, but yeah, it gives us the endpoint. So let's open up Postman, or you can just do a curl request on your terminal, but I'm going to use Postman, and let's send a post request to that URL. So we can copy and paste the URL from here. Post request, and in our body we want name field. I'm just call this test user, and then an email field which we'll call test email at gmail.co.uk. Send that. Hopefully we get internal server error. Okay, so you might hit this. Maybe I've used the wrong keys. Name and email. Let's see. Body.name, body.email. No, so it doesn't look like that. So here, the easiest thing to try and debug this is just to add a console.log event, and we can use that to see what event the Lambda's getting. So again, we're just going to deploy this. Once that's deployed, oops, where's my AWS console gone? Once that's deployed, we can just keep an eye on that in the background. We can look at this tab here, monitor, and because Serverless has created a log group for us for the Lambda function, we should be able to look at logs here. So if we look at the last one, it's saying cannot find module create customer. So that is possibly it's not getting the right path for the function. So let's look at the path for the function. We have got source create customer dot create customer, source create customer, create customer. So the function seems to be there. That all looks okay to me. So it's deployed now. So let's hit it again and see what event we're getting. But it might not be an issue with the event then, if it's saying cannot find the module. So if we hit it again, we should get another internal server error. But now, let me show you this. So even if it's not useful for us just now, it's useful for debugging. So that was at 40. Oh, so yeah, sorry, because it's not even finding this function, it's not able to log the event. So I'll pause the video for a second and try and work out why it's not finding the function. Okay, there must have been something wrong with my path in here, because I moved it out of source and moved the function to just the root and create customer dot create customer. So not 100% sure why that was, but it seems to be working now. So we've got a different error actually, which I thought I'd stop and show you. So if we look at the log, I just fired off an event, same event, and we get this log, access denied exception. So user, basically it's not able to put the item in DynamoDB. So we need to create an IAM resource for the Lambda. We can do that under provider, and it just attaches the IAM resource to all of our Lambdas. So let's say IAM role statements, and here we'll say allow action, and then I'm going to copy and paste some actions in to save a bit of time. But we want put item, get star, scan star, update item, and delete item. And then the resource which we want that on is the ARN of our Dynamo table, which is looks like this. So we can get AWS region, that's CloudFormation gives us that, and then we need AWS account ID. That should be capital I. And then colon table / our table name. So here we can just paste in this again. So you see why that's useful to have it defined just in one place. Okay, now we run serverless deploy. Oops, not like that. Serverless deploy. And wait for that to deploy again. Okay, that's deployed. Let's go to Postman again. Flow star user. And we get a 201 response, so we can assume that's created. So next we could go into our DynamoDB table and have a look, but I'm just going to move on for speed just now. So next we're going to create a function called get customers, and we can use this to see if it has worked in a second. So same thing as before, we're going to have a get customers file in our serverless file. We don't need hello anymore, so let's just change this to create customer, and that's going to be our get method. And I think that's all we need to do there. Yeah, create customer, sorry, this should be get customers. And then the function will be called get customers as well. So back in our get customers file, and we're going to import the AWS SDK again. And then export a function called get customers. This one's going to be a little bit longer, but again, not too long. Okay, we've taken our event, and remember how I said our DynamoDB environment variable is available to all the functions. So here we're going to make use of that. Scan parameters, it's going to be the table name, process.m.dynamodb customer table. DynamoDB, we're going to set up an AWS client. And then I'm going to say the result is await DynamoDB.scan scan parameters.promise. Okay, so if this was a big table in production, you probably wouldn't want a method like this where you can just scan the whole table, but it's not, so we're going to do it. And we're going to say if nothing's returned, then return status code 404. Otherwise, we're just going to return everything that was returned to us. So with a status code 200. And that's going to be JSON.stringify. Total is result.count, and items is await result.items .map, and customer goes to, so the name, remember, was primary key, and then the email should just be email. Okay, and that's written. Hopefully one last serverless deploy. Okay, that's deployed. Let's bring up Postman, and this time we want to send a GET request to the same URL, and you can see here we get the user we created before. So let's just create one more, double check it's working. Name, this time let's say another user, and then email, we'll just say email@email.com. Send that off, get a 201 back, then send a GET request, and this time we get 2 items, another user and test user. So hopefully you found that useful. Let me know if you run into any issues, and I'm happy to help out. One thing, say at the end, you should run serverless remove if you're not using the application, and it will just tear down all the infrastructure. So please subscribe if you found that useful, and yeah, I hope to see you in future videos.